In this video, we're going to look at questions number 5 and 7 of your test review. On question number 5, we're given that the cosine of 7 pi over 6 is negative square root of 3 over 2, and the sine of 7 pi over 6 is negative 1/2, and we're being asked to find the values of the other 4 trig ratios. So I'm going to start with tangent, and tangent of any angle, just in general, tangent theta is equal to y over x. And we need to remember that cosine theta is equal to x over r. Sine theta is equal to y over r. And in this case, these are unit circle values, so we're going to assume our r is 1. And so to find tangent of 7 pi over 6, we're going to do the y-coordinate, which is the sine value, negative 1/2, divided by the x-coordinate, which would be the cosine value, negative square root of 3 over 2. Now, when we're dividing by fractions, we need to multiply by the reciprocal. So I'm going to keep the top fraction as it is and multiply by the reciprocal of the bottom fraction. I have a 2 in the top and the bottom, and everything's being multiplied here, so those can cancel out. I have a negative times the negative, which makes this positive 1 over the square root of 3. And I can't leave that radical in the denominator, so we're going to rationalize by multiplying by the square root of 3 over the square root of 3. And in my numerator, I get the square root of 3. And in the denominator, the square root of 3 times the square root of 3 is the square root of 9, which is 3. And so that's my tangent value, square root of 3 over 3. We also need to find our secant value. And secant theta, secant is the reciprocal of cosine, which is r over x. So secant of 7 pi over 6 is going to be our r, which is 1, over the cosine value, which is negative square root of 3 over 2. So again, we are multiplying with fractions. So we're dividing with fractions. So we're going to multiply by the reciprocal. On the top I have 1. I'm going to write that as 1 over 1 times the reciprocal of the denominator, 2 over the square root of 3, and that's negative. So we get negative 2 over the square root of 3, and once again, we can't leave that radical in the denominator. So square root of 3 over square root of 3, and on the top, I get negative 2 square root of 3, and on the bottom, again, we get 3. All right, next up is cosecant. Cosecant theta is the reciprocal of sine. This is going to be r over y. So cosecant of 7 pi over 6 is going to be the r, which is 1, over the y-coordinate, which is negative 1/2. And so that would equal 1 over 1 times the reciprocal, which would be negative 2 over 1. And so we just end up with negative 2 for the cosecant value. Last up is cotangent of 7 pi over 6. And cotangent is equal to x over y. It's the reciprocal of tangent. And so this is going to be the x coordinate, which is negative square root of 3 over 2, because that's the cosine, over the y-coordinate, which is the sine coordinate, negative 1/2. One more time, we're going to multiply by the reciprocal. I'm going to keep the top fraction as it is and multiply by the reciprocal of that bottom fraction. And my 2's cancel out. Negative times the negative is a positive, square root of 3. All right, question number 7. In question number 7, we see that Jackson is riding a Ferris wheel with diameter 120 feet. boards the Ferris wheel at the bottom at time t equals 0, and the Ferris wheel takes 10 minutes to complete a revolution. And Jackson rides this Ferris wheel for 1 hour. And the first thing we're asked to do is sketch 2 cycles of the graph of Jackson's height. So we're going to make a graph here, and first thing we need to do is figure out what we're going to count by down here to label the axis. So if it takes 10 minutes to go all the way around, and I want to sketch 2 cycles, that means that on the x-axis, I need this to go out to 20. So if I've got 8, I'm going to make this last one be 20. The fourth one would be 10. And then 5 and 15 in the middle there. And of course, this axis is time in minutes. Now on the other side, we're sketching the height, how high Jackson is. So this is our height in feet. And the diameter of the Ferris wheel is 120. So we're going to go up to 120, and then I'm going to also mark off a 60 for the halfway point. All right, so let's sketch our graph. Jackson's getting on at the bottom at time t equals 0, so I know that's going to be our value there, and it takes 10 minutes to go all the way around, which means at time 10, we're going to be back at the bottom, back at 0. Halfway through is when he's going to hit the high point. He's going to be at the top of the Ferris wheel at 120. That's going to happen at 5 minutes. And then at 2.5 minutes, we should be halfway to the top. And at 7.5 minutes, we should be halfway back down. And then the next cycle is just going to repeat the same pattern. At 15, he's up at the top. 12.5, it would be halfway. 17.5, halfway back down, and 20 minutes, we're back at 0. And so we're going to connect these points. And there's a graph of his height around the Ferris wheel. All right, next part of this question asks us to determine the amplitude and the period of the graph that we drew in part A. So I've got another sketch here of the graph for us from part A. Now remember, the amplitude is the distance to the top or the bottom, to the highest point or the lowest point from the midline. Now my midline is going to be here at 60. And so my amplitude is either that distance or this distance, which they should both be the same. In this case, amplitude is going to be 120 divided by 2, which is 60 feet. The period of the graph is the amount of time that it takes to complete one cycle, and in this scenario, that time is 10 minutes. All right, next up, the question asks, how high off the ground will Jackson be when he has been on the Ferris wheel for 15 minutes? Now, for this first one, we can just look on our graph and we can see that at 15, that's in the middle of a cycle around the Ferris wheel. And so, of course, he's going to be up here at this highest value at 120 feet. What about at 42.5 minutes? Okay, so this one we're going to have to think about a little bit more. Remember that our period is 10. And so I want to think of a number close to 42.5 that's divisible by 10. So, of course, that would be 40. And what that means is that I know that every 10 minutes we're back at the bottom of the cycle. So when time equals 40, I'm right back here at the starting point. And so 42.5, that would equate to this time value here of 2.5. And we can see on our graph here that he's going to be at 60 feet.